Okay, so after we learned the fundamental theorems, part 1 in section 5.4, right now I would like to talk about another fundamental theorems, part 2. Okay, this is what we call the definite integrals. Okay, so you will see that to the definite integral is that if f is continuous on AB and capital F, is the antiderivative of f on AB, then the integrations from a to b, the integral from a to b of f of x dx, it will be the antiderivative we evaluate at the endpoint, capital F of b minus capital F of a. It will be equal to, that means this is another notations, okay? Then this integral, this theorems right here, tell us that if we know an antiderivative f, the capital F of f, then we can evaluate the definite integral, this one right here, okay, simply by subtracting the values of capital F at the endpoints of the integral from A to B. Okay, but this is a really powerful concept. Okay, so in this case, now here is some terminology that we could learn. We actually, to this one, the A and B, A is what we call the lower limit, and A and B is the upper limit. Basically, it's just if we have a functions, okay? If we have a function like this one right here, this is the function f, then now A is my lower limit and B is my upper limit, okay? And of course, d of x, the x right here is tell us that the function is depend on x then. Is equal to, now this f right here is the antiderivative. Then we could evaluate the capital F, okay, at B minus the capital F at A, okay. Then this is actually, again, this is just a shorthand notation right here, okay. Okay, so now, basically we could actually do this, okay. So now you will see that in section 5.1, we are using the Riemann sum to help us to to find the area, right, under the function between the lower limit and the upper limit. And now we could actually using this, the definite integral, to help us to do the problem, okay. Now here, we have to this table right here, okay, we call this indefinite integral. Now, what is the difference between the definite integral and indefinite integral? Definite integral, the result, the answer is a number, okay. However, the indefinite integrals is actually give us a function, okay. Now you will see that this is exactly what happened. So therefore, again, you have to be careful, okay, about the terminology. Indefinite integral, the result is a function plus a constant c. The definite integral is a number. Okay, okay, so then now let's see how do we actually work on this problem right here. Okay, now to the first problem, I would like to sketch the regions under the graph of the function and find its area using the fundamental theorems, part 2 then, okay? Okay, then now of course to this one right here, we could, I have f of x is equal to x and 2 minus x, okay? Then now, basically to this one right here, I have the x-intercept is 0 and 2, okay? And one thing about this is you will see that what happened here is that this means the coefficient of x squared is a negative, meaning the parabola is open down, right? Okay. Okay. So right now, what we are looking for this area right here. Okay. Okay. Then now, let us try to finish this problem now. So how do I set it up? So then, in this case, I will have A is integrate between 0 and 2 of the integrand, which is 2x minus x squared dx. Okay, so that's it. So this is how we set it up. Okay, and then now what we could do is, again, in the section of 4.8, when we talk about the antiderivative, we know how do we do this is basically we could make this become 2, maybe let me do it this way. Integrate between 0 and 2 of 2x dx minus between 0 and 2 and x squared dx, right? Okay. Then, of course, to this one right here, we could take the 2 out. Okay, so now, then, do you remember how do we do this? How do we actually take care of the, again, definite integral? Okay, so in this case, you have to remember that this one right here. Okay, so if we have, again, to this one, basically is kind of like we could use x to the n, right? The integrand is x to the n, then we work with this. So then now, we are going to have 2 times x squared over 2. And then minus this one will be x to the power 3 over 3. Okay, then, of course, in this case, you will see that 2 and 2 cancel out. Okay, now, one thing about this is what we could do is we could actually combine them together. So I will have x squared minus x to the power 3 over 3 integrate between 0 and 2. Okay, now to this one, basically what we are going to do here is we are going to rewrite this into 2 squared minus 2 to the cube over 3 minus 0 squared minus 0 to the cube over 3. Okay. Okay. Now, what is going on here? Let me do this. Now, here basically is your antiderivative, right? So this is your capital F of x. So right now, what I did here is I am going to have the f of 2 minus f of 0, okay? So therefore, this right here is f of 2. This right here is f of 0, okay? Then, of course, right now, what we need to do is we need to simplify. So I will have 4 minus 8 over 3. Then, of course, you will have this one right here is 3 times 4 is 12 minus 8 over 3. So my answer is 4 over 3. Then, yeah, that's it. So this is my answer here now. So then it's telling me that this area is 4 over 3. Then. Okay, so then now let us try to evaluate the following definite integral using fundamental theorems now of calculus. Okay, so to this one right here, basically you will see that here is we will have 2x, we evaluate between 0 and 9, right? Then now, then I will have 2 times 9 minus 2 times 0. So therefore, in this case, my answer will be 18 then. Okay. And now, again, maybe let me write this. So, okay. Now this is actually is the antiderivative right here of x to the n. So to this one right here, I'm going to have integrate between -2 and 2. Maybe I just write it. It will be 10 x to the 9 plus 1 over 9 plus 1 plus 3 x to the 5 plus 1 over 5 plus 1, right? We integrate between -2 and 2. then now you will see that these two cancel. So I have x to the power of 10 minus this and this 2, no, plus, right? X to the power of 6 over 2. Okay, so after we have this, then what we need to do here is I will have 2 to the 10 minus 2 to, plus 2 to the 6 over 2, subtract negative 2 to the 10 and plus negative 2 to the 6. Okay. Then, of course, you know that 2 to the 10 and negative 2 to the 10 is the same. 2 to the 6 over 2 and negative 2 to the 6 over 2, again, is the same. Then we subtract. Of course, my answer will be 0. Okay. Yeah. Okay, so then now it is your turn to try to, again, work on like C, D, E, and F. And then how do we actually do this type of problem? Basically, we could use this table right here to help us to do this, okay? Now, one thing about this is, to this one, to D, let me write down. The antiderivative of the cosecant square of kx dx is actually equal to the derivative of cosine, cotangent. Okay, so this is actually is the antiderivative of the cosecant square of kx. Okay, now later on I will show you why we have 1 over k here when we get to the section is by using substitutions. But right now, just know this is the one. Okay. Okay. Then. Okay. So let me work on the problem C, D, E, and F. Okay, to finish this 4 problem right here. Okay. Okay. Now to this one right here. Basically, if you remember the integral of sine of x dx, basically is a negative cosine of x. Okay. Plus c, right? Because the derivative of negative cosine of x is sine of x. Then we are going to evaluate between 2 pi and 4 pi. Okay? Then now I will have negative. Okay, so I will have cosine of 4 pi minus cosine of 2 pi. Okay. And now we know that cosine of 4 pi basically is 1, and cosine of 2 pi is also 1. So therefore the answer is 0 then. Okay. Okay, then now how about D? Okay, so to this one, again, just like this one, so I have 1 over 7 cotangent of 7y, and then integrate between pi over 28 and pi over 14. Okay. Then of course, to this one, we could have 1 over 7 cotangent 7 times pi over 14 minus cotangent 7 times pi over 28. Then now I will have 1 over 7. Okay, so I have cotangent of pi over 2 minus cotangent of pi over 4. Then now, my bad, there must be a negative sign right here. Okay. So cotangent of pi over 2 is 0 minus cotangent of pi over 4 is 1. Okay. So therefore the answer in this case is 1 over 7. Okay, so now let us try the next one. So if you remember this, basically is you could consider that this one right here is 1 over x dx, okay? So then it will be natural log of x plus c. Then, of course, to this one right here, we will have natural log of absolute of x, and then you evaluate between -12 and -4. So I will have natural log of -4 minus natural log of -12. Then, of course, we will have 4 over 12. So basically, I have natural log of 1 over 3. And to this one, if you remember that we could write down as natural log of 1 minus natural log of 3. So the answer is negative natural log of 3. Wow. Okay, so now you will see that to the f functions, the f problem f is kind of complicated. So to this problem right here, what I'm going to do is actually I would like to separate this into two terms. Okay, so you will see that this is from 4 to 9 x over x to the power 3 minus x to the 1/2 x to the power 3 and then dx. Okay. Then we are going to simplify from 4 to 9. So this is x to the -2 minus x to the -5 over 2 dx. Okay. And then now we could apply the rule now. So I will have x to the -2 plus 1 over negative plus 1 minus x to the -5/2 plus 1 over -5/2 plus 1. Okay. Evaluate between 4 and 9. Then of course, this one right here, you will see that this is negative x to the -1 plus this one, -5 over 2 plus 1 is -3 over 2. So negative being positive. So therefore, I will have 2 over 3 here, x to the -3 over 2. Okay, so then now, what we want to do is we are going to evaluate. Okay, so in this case, let me modify this a little bit. Okay. Then now I will have -1 over 9 plus 2/3 times 1 over 9 raised to the power of 3/2. Okay, and then minus -1/4 plus 2 over 3 times 1 over 4 raised to the power of 3/2. Okay, then now I will have this one is -1/9 plus 2 over 3. So again, remember 9 basically is 3 squared. So I will have 1 over 27 minus -1/4. Let me do this. Plus 1/4, and then plus. Now this is basically is 2 squared. So I will have 2/3 times 1/8. Okay, then now after we have this, then what we want to do is I would like to simplify this then. So I will have -1/9 plus 2 over 81 plus 1/4 minus 24 2. 112. Okay. Okay, so then now what we are going to do here is Okay, so then let me see. I have 81, 9, 4, and 12. So basically, what I'm going to do here is I will have 27 times 9 times 4. Okay, so um, plus 2/81, and then this one right here is multiplied to 12, and then plus 1/4. So I have 81 times 3, and then minus 1/12 times 81/81. Okay. Wow, it's a little bit messy, but again, if we have a calculator, then we could actually do this. Okay. Okay. So now the answer that I have is 13/162. Okay. Okay. So just up to this point, maybe we could use just use calculator. Okay. Okay. Just long. Huh? Okay. Then now let us look at the next problem now. Okay. So to this one, then of course we know that to this we have secant square theta. D theta basically is a tangent of theta plus c. The reason is the derivative of tangent of theta is secant square theta, right? So then now we will have tangent of theta evaluate at between -4 and x. Okay. Okay, so to this one right here, then what do we have? We are going to have tangent of x minus tangent of -4. Then, of course, to this one, I will have plus tangent of pi/4. The reason is tangent is odd function, right? Okay. Okay, so then you will see that now my answer is a tangent of x plus 1. Okay. Then how about this one? So I will have this one is natural log of t evaluate at between 2 and square root of x. Okay. Then in this case, I will have natural log of square root of x minus natural log of 2. Okay. And remember the domain of the square root of x basically is when x is greater than 0, then this output is always positive. So I will have this. Then, of course, we could rewrite this into natural log of like √2 of square root of x over 2. Or we could make this become 1/2 natural log of x minus natural log of 2. Something like this. Okay, so then the next one right here is I would like to find the area of the regions. We would like to find the area of the regions bounded by the function, the graph of f and the x-axis on given interval. what I'm going to do is I would like to grab the function first. Okay. So to this function right here, we know that we have a zeros at x equal to 0, x equal to -1, and x is equal to 2. Okay. So therefore, in this case, then okay, and now we are going to have a -1, 0, 1, and 2. So the function basically is go for this point, go for this, and then go for this. Okay. So you will see that this function basically is a cubic function. So then that means the function that I have probably is like this. Okay. Okay. Then now I would like to find the area of the region bounded by the function and the x-axis. Basically, what I'm looking for here is I'm looking for this area, okay, plus this area. Okay. Now, one thing about here is you have to understand that this one right here basically is a positive here, then this is a negative. Okay. So therefore, in this case, if I want to find the total area, what do I need to do? I need to separate how I integrate it then. So what I'm going to do here is I would like to have to find the total area. Okay, it will be what I integrate between -1 and 0 of f of x dx. And then because this area right here is a negative, so I will subtract the integral between 0 and 2 of f of x then. Okay, so this is what I'm going to do. Okay, so then now we are going to have this of let me modify this. So I have f of x equal to x times x plus 1, x minus 2. So this is x squared minus x minus 2. Okay. So I will have x to the power 3 minus x squared minus 2x dx. And minus between 2 of same thing. Okay. Okay, then now it is x to the power 4 over 4 minus x to the power 3 over 3 minus 2 times x squared over 2 minus same thing here. Okay. Okay, so then now let us try this. So I will have evaluate as 0, so I will have 0 minus -1 to the 4 over 4 minus -1 to the cube over 3 minus -1 square, and then minus, okay, the whole thing. So I will have 2 to the 4th over 4 minus 2 to the cube over 3 minus 2 square, and then subtract 0. Okay. Okay. Then now let's try this. So I will have -1/4 minus 1/3 plus 1 minus 16 over 4 plus 8 over 3 and then plus 4. Okay, then now what I need to do here is I will have the LCD is 12. Then I will have this one is 3 over 12 minus 4 over 12 plus 12 over 12, 48 over 12, 32 over 12. Ooh. Kind of stupid, huh? Okay. Okay, so then now what I'm going to do here is I will have this one is 48, 44, 41. Oh. This is 5. Oh, this will be 37. Okay, so then now this is what we have here now. Okay. So therefore, again, now remember, if the problem asks you to find the total area, what you need to do, basically, you need to sketch the function first to see which function is below the x-axis. Okay, if it is below the x-axis, what you need to do is you have to make it become a positive, like this one. Okay, so now try this B. Okay, I hope that you still remember how to sketch the side functions. Okay. Okay. Of course, this one is between 0 and 2 pi, but right now I need to have this between negative power 4. Okay, and now I will have this one is pi over 2, this is pi, and this is negative pi over 2. Okay, so I'm looking for between negative pi over 4, so it's from here to 3 pi over 4. Okay. Okay, so then now, if I want to find a total area, it will be negative integrate between negative power 4 to 0 of sine of x dx plus integrate between 0 and 3 pi over 4 sine of x dx. Okay, so this is what we have. Okay. And then now we will have a negative. Okay, so we know that to this one is a negative cosine of x. Okay. Integrate between negative power 4 to 0 minus plus negative cosine of x, integrate between 0 and 3 pi over 4. Okay. Okay. And now I will have this one will be cosine of 0 minus cosine of negative power 4. Then subtract cosine of 3 pi over 4 minus cosine of 0. Okay, we have this. And then now, of course, we know that cosine of 0 is equal to 1. And cosine of negative power 4, basically just cosine of power 4, because again, cosine is even. So I have 2 over 2. And then minus this one, 3 pi over 4 is in quadrant 2. In quadrant 2, cosine is negative. and then minus 1. Okay. And now I will have 1 minus root 2 over 2 plus root 2 over 2 plus 1. So my answer will be 2. Okay. Okay, so now the last page basically is kind of like graphical insight. What is this? What is going on about the integral? Okay, so this one right here. Now remember, if the function is about the x-axis, that means what we are talking about the positive kind of like area here. Okay, so the area is increasing here, and then when the function is below the x-axis, basically in this case right here is actually below. So therefore we have a negative area. So we are going to decreasing in area and then increasing in area. Okay. So on the other hand, this one is kind of like the derivative of the a function. Okay. So then basically in this case, about the x-axis, meaning what the original function is increasing. You could consider, maybe I should say that here, you could consider that this is f prime, and then this is your f functions right here, okay? So that means the function is increasing, and then between this interval right here, the function is decreasing, and the function is increasing again, okay? So you could actually think of this way too. Okay, then now, what I'm going to do here is, I would like you to actually match the A, B, C, D to capital A, capital B, capital C, and capital D. Okay. Same thing, you could consider that this one right here is actually is your derivative. Maybe let me use a different function, right? And then the function here is actually is kind of like your f functions. Okay. Okay, now go ahead and try this problem. Okay, so now then let's try this. Now to this one right here, you will see what happened is at x equal to 0, then the area basically is, again, you will see that this area is increasing, right? The area is 0. And then when it's in increase, then what happened? The area is increased. So therefore, in this case right here, to this A right here, the possible answer will be C and D. Okay. Then which one should be correct? Okay. Now, one thing about this is you will see that what happened to the area. The area is actually is increasing as a weight. Okay, it's a constant weight right here. So therefore, in this case, I believe that okay, this answer right here, it will be, it matches to A then. Okay. Oh, to C. Okay, C is the one. Okay, then now let us look at this one now. So to this one right here, you will see that again, the area is positive area, okay, is increasing. However, to this one, what happened is the function is decreased. So at this moment, it's from increasing to decreasing. So then in this case right here, probably B is the answer. Okay. Okay, so to this one right here, again, one thing about this is you will see that the area is always positive. That means the function is increasing, okay, the original functions. And then what happened is you will see that to this one is increasing slowly and then is increasing more and then slowing down. So therefore, in this case, I believe that D is the one. Okay. And now, how about D? Now you will see that to this one right here, we start with the negative, or the function is decreasing first and then increasing, right? So then, of course, to this one right here, A will be the one that is decreasing first and then increasing then. Okay? Yeah. Okay, so that is it for this section. Okay. So then we have learned how to evaluate an integral, right? With a definite integral. Okay. Okay, so thank you.